New branch in family tree of exoplanets discovered. I printed this out from Science Daily. Unfortunately, they're a bit misguided in a way. I'll explain why. The sketch here illustrates a family tree of exoplanets. This is according to them. Planets are born out of swirling disks of gas and dust called protoplanetary disks. The disks give rise to giant planets like Jupiter, as well as smaller planets mostly between the sizes of Earth and Neptune. Researchers using data from the W.M. Keck Observatory and NASA's Kepler mission discovered that the smaller planets can be cleanly divided into two groups: the rocky Earth-like planets and super-Earths, and the gaseous mini-Neptunes. If you'll notice here, they have protoplanetary disk, and then that breeds all the other objects. It's right on the web page if you want to go look at it yourself. But essentially, they're completely missing the point as usual. The planet formation happens inside the star itself, and the end product is only apparent after the evolution is finished. Which means that disk up there, that's not even needed. It happens internally. You'll have the Neptune coming to be after the thick atmosphere of Jupiter is dissipated and the leftover remains are there. And then once the Neptune dissipates, it exposes its rocky ball in the center. That's the new Earth. These are not individual lines of evolution here. They are one and the same. Now, what I notice here is they don't quite see that here. And this page, this goes over it more in depth here. It says the California Kepler survey, a gap in the radius distribution of small planets. They'll have here in the abstract, they say objects which are there's two main groups here. You have an object that is 1.5 the radius of Earth and below, and you have objects that are between 2 and 3 Earth radiuses. And you'll see that in their abstract here. And all these objects have periods, which means years of less than 100 days. And I went ahead and highlighted those two parts for you right there. I'll link this to the bottom of the page as well. So what they're saying is, they say that there is a gap between the sizes of these objects. So they'll have an object this size and an object this size, and then there's nothing in between. The gap is 1.5 radius and 2 radiuses of the Earth. Now, what I see here is, if you go on the exoplanet page where exoplanet.eu is, what they'll do is you can sort the data here, and I went ahead and printed out all the objects between 1.5 and 2 radiuses of the Earth that the Kepler has found. Check out all those. That's about 35 on that page. 35 on this page. 35 on this page. 35 on this page. On and on and on and on and on and on and on. About 400 objects between 1.5 radius of the Earth and 2 radius of the Earth. So the fact that they say they are there's a paucity of them, which means there's a scarcity of them right in the abstract, is kind of weird. They say here, the paucity of planets between 1.5 and 2 radiuses of the Earth supports the emerging picture that close-in planets smaller than Neptune are composed of rocky cores, blah, 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 blah. They don't know why these objects have rocky cores. there's no scarcity of objects between 1.5 and 2 radiuses of the Earth. That's a complete, it's not a falsehood, much less because the data that they have is probably outdated. It's just misdirection. It's them wanting to make it feel as if the people they're talking to, or as if they know what they're doing, but they actually don't know what they're doing at all. They had to make an excuse somehow. They had to find something that went ahead with what they already believed, but there was no physical mechanism there at all to form those rocky objects. As well, we can see that here is, it says here, the distinction between rocky and gaseous planets reflects the typical core sizes of planets, as well as the physical mechanisms by which planets acquire and lose gaseous envelopes. And that's really strange. And if you'll notice here, they have that written right here. You'll see it for yourself. How exactly does a rocky object acquire an atmosphere? They don't know how that happens. To them, they ask the question, how do rocky objects acquire their atmospheres? And the answer is they never formed without them. They assume that rocky-like objects like Earth were always like Earth, and then they just acquire a thicker and thicker atmosphere as they evolve. That doesn't make any sense at all. They should have asked the question, what would happen if Neptune or uranium lost its atmosphere? What would that look like? They should have asked that question. And if they would have asked that question, which is answered by stellar metamorphosis, you'll have a Neptune lose its atmosphere, become a mini Neptune, and then become an ocean world, and then become, which is, a super Earth, and then you have an Earth. So it loses its atmosphere as it evolves. So to answer the question, what is the physical mechanism with which a planet acquires its atmosphere, would be by continual loss via radiation, evaporation, photodissociation, atmospheric escape, magnified by hotter hosts, as well as internal heat production, and self-radiation, self-evaporation, self-flaring, because the star was much larger and hotter in its past, just like the sun, where it's losing matter to solar wind and flaring and coronal mass ejections. When the star was much, hotter and larger. So they have it backwards yet again. And you'll see that when you read these papers. As well, a little bit further down here, it says, however, a small amount of hydrogen and helium gas added to the roughly Earth-sized rocky core can substantially increase planet size, without significantly increasing planet mass. For this reason, it has been suggested that the radii of sub-Neptune-sized planets, along with knowledge of the irradiation history, would be sufficient to estimate the composition without additional information. Now, what you'll see there is, along with knowledge of the irradiation history. That essentially is asking the question inside of stellar metamorphosis theory, which stars did these objects orbit in their past and how close? Because clearly, the irradiation history of Jupiter around the sun right now would not allow it to lose mass at a very fast rate versus hot Jupiters. And where Neptune and uranium are right now, there's no way they would lose a lot of mass given their distances. That means they were orbiting a much hotter, younger star before they were adopted by the sun in their past. And probably many other stars before that, as well as the Earth, Mercury, Mars, Venus, and all the others. But, so irradiation history, that opens up a whole new can of worms, and I don't think that they're prepared to answer that question. Because to them, all the objects in our solar system as they stand right now have always been orbiting the sun, and they haven't moved much since their formation, which is a completely different worldview as opposed to stellar metamorphosis. Let's see another few notes here. And just to reiterate the problems with establishment astronomy and why they are not trained with the appropriate mindset in mind. They don't have the correct way of looking at problems because of their training in school. Sure, the way they look at the problems is useful, but it's not an all-encompassing, this is the one single way you look at all the problems in the universe and we can answer all the problems using this. They take that arrogant approach. And if you take the arrogant approach that your way is the best way and all the other ways are nonsense or don't ever work, what you're going to do is miss huge amounts of information out there, and you're going to misinterpret a vast amount of information, and you're going to be confused and lost. And that's exactly what's happening to these people. They're so arrogant, they're so set in their ways, that their way is the best way and everybody else's way is not worth the time and effort to examine fully. And I'll explain what the difference is between their training, which is analysis of data, and the way I look at it, and the way my listeners should look at it, is synthesis of data. Instead of taking information that you see in the sky and clumping it into little boxes and compartmentalizing it, you need to take all those little boxes and find out what they have in common with each other. You have to synthesize the data instead of breaking them apart into little bits and pieces. And we know this because in the Science Daily page, says here, Fulton, a graduate student, said, astronomers like to put things in buckets. They do like to put things in buckets. They like to compartmentalize the shit out of everything because it's easier to deal with. It's easier to manage the data. And that being said, the main difference between synthesis of data and analysis of data would be like looking at rough endoplasmic reticulum in a cell body with ribosomes. So you'll see a bunch of random dots scattered about. This is connecting the dots. This is making a clear picture of what you're looking at when you see something through a microscope using all the data points. And we can do that easily because it's already put together for us when we look through the microscope. The organelle is clear right in front of us. But given the stars don't have dots connected to them, with their evolutionary timelines, it's a lot different to do that with the stars. So you have to kind of like use your imagination and look at their actual physical characteristics to draw in gaps in knowledge that weren't there previously. What they do is they analyze the shit out of the data. Instead of seeing the rough endoplasmic reticulum with the ribosomes, they see 4 fields. They see 4 distinct fields, and this would represent, the mini Neptunes, the Neptunes, the super Earths, and the Earths. And they don't realize that they're all one and the same. They're all one evolutionary path. So basically what they do is they group things together inside of fields, and I think that has to do with their mathematical training. If you have training in math and you don't know how to use the math appropriately, what it's going to do is bite you in the ass later down the road. And for the main point of this talk, they essentially drew a gap. They drew a majority of objects right here and a majority of objects right here, and there's a gap. There's a missing gap. We know there isn't a gap because Kepler has already filled that gap in. But basically, I just wanted to point out that that was misdirection. There is no gap. The reason why they wanted to make a gap is because they wanted to justify some of the ideas and make it look like they knew what they're doing, but they don't know what they're doing. And finally, last but not least, a star's evolutionary timeline is parallel to life's evolutionary timeline. The end of a star's evolution signals the maximum life could have evolved on it, and it means life like us had to have come from a star at least as old as Earth, more or less, given a couple million years or so. And that's actually very different than, what they believe how life forms. But, alright, I made this video way long enough. Y'all, take it easy.